Hello everyone. Today we will solve a type of question, an experimental type of question, which is the empirical molecular formula in stoichiometric relationships chapter. And we will try to determine the empirical and molecular formula of an organic compound X by using the masses of X, carbon dioxide and water in a combustion reaction. And just to remind you, empirical formula is a formula that shows the simplest whole number ratio of the atoms, whereas the molecular formula shows the actual number of each atom in a compound. Before we start solving, let me read the question. We have an organic compound X, and it contains only carbon, hydrogen, and oxygen. And we know the mass of X, which is 1.112 grams. And oxygen is in excess, which means X will be the limiting reagent. And we have 2.640 grams of carbon dioxide and 1.352 grams of water. And the question says, what is the empirical formula of X? And if the relative molecular mass is 74.14, what is the molecular formula of X? So before we start solving, we need to write the chemical equation between X and oxygen to form carbon dioxide and water. In combustion reactions, oxygen is always the reactant, and if we have an organic compound containing carbon and hydrogen or carbon and hydrogen and oxygen, we produce carbon dioxide and water. This is called complete combustion. And we don't know the molecular formula of X yet, that's why I cannot balance the equation. We don't know the coefficients for now. Okay, so how do we start solving this question? First, let's write the given masses under each species. And we have 1.112 grams of X. And we don't know the mass of oxygen, let's say 8 grams. And for carbon dioxide, we have 2.640. And for water, we have 1.352. By using the law of conservation of mass, we can equalize the mass of the reactants with mass of products. So we can write a mathematical equation like 1.112 plus A must be equal to 2.640 plus 1.352. And it makes 3.992 grams. So the mass of oxygen, which is A, must be equal to 3.992 minus 1.112 grams, and it makes 2.880 grams. Now we know the masses of each species, and we need to continue by finding the number of moles of each. We cannot determine the number of moles of X because still we don't know the molecular formula and we don't know the molar mass. But we can calculate the number of moles of oxygen, carbon dioxide and water because we can calculate their molar masses. And if we know the mass of a compound or any species and we know the molar mass, then by dividing mass into molar mass, we can calculate the number of moles. This is our formula. So I will try to calculate the molar mass of each species. We have oxygen first. We have 2 oxygen atoms and the atomic mass of oxygen is 16. So the molar mass of oxygen gas is 2 times 16, and it makes 32 grams per mole. And for carbon dioxide, we have 1 carbon atom and its molar mass is 12.01. And plus we have 2 oxygen atoms and 2 times 16 comes from oxygen. In total we have 44.01 grams per mole. And for water molecule, we have 2 hydrogen atoms and molar mass of hydrogen is 101, plus we have 1 oxygen atom which is 16, and in total it makes 18.02 grams per mole. Now to find the number of moles of each species, we need to divide their masses into the molar masses. So let's write the equation again. And let's write the masses under. We have 1.112. We have 2.880 and we have 2.640 and we have 1.352, and we divide them to 32 for oxygen, 44.01 for carbon dioxide and 18.02 for water, and this is still unknown, we don't know it yet. So the number of moles of oxygen will be 0.090 moles. And for carbon dioxide it is 0.060 moles. And for water it is 0.075 moles. So when we find the number of moles of each species except X, we can calculate the number of moles of each atom in the product site. What do we mean by the each atom? We have carbon atom, we have oxygen atom, and we have hydrogen atom. So how many moles of carbon, oxygen, and hydrogen do we have in the product site? We need to calculate this, and it will be equal to the number of moles of carbon, oxygen, and hydrogen on the left-hand side, which is the reactant side. So let's start by doing the number of moles of carbon and oxygen in carbon dioxide. We have 0.060 moles and we have carbon dioxide. So number of carbon is 1, number of oxygen is 2. So how many moles of carbon do we have? We have 0.060 moles. And how many moles of oxygen do we have? 2 times 0.060 moles. And it makes 0.120 moles. And if you look at water case, it is 0.075 moles. And we need to multiply by 2 for hydrogen atoms, it is 0.150 moles. And for oxygen, since we don't see any number, it is 1. So it is 1 times 0.075, which is 0.075 moles. Okay, so on the right hand side, which is the product side, the total number of hydrogen, carbon and oxygen are 0.060 moles, and this will be 0.150 moles. And oxygen comes from the two compounds. Let me show it to you. 0.120 comes from here, and 0.075 comes from water. So we need to take the sum of them, and it makes 0.195 moles. So on the reactant side, we need to have 0.060 moles of carbon, 0.150 moles of hydrogen, and 0.195 moles of oxygen. But we also have an oxygen molecule here, and it is 0.090 moles. So some of the oxygen comes from here, and the rest is coming from X. So let's calculate how many moles of oxygen do we have in 0.090 moles of oxygen molecule. Since we have 2 atoms inside the molecule, we need to multiply by 2. And it makes 0.180 moles. So all others are coming from the compound X, and we have carbon 0.060 moles, and we have hydrogen 0.150 moles, and for oxygen we need to subtract 0.180 from 0.195, and it makes 0.015 moles. So after we find the number of moles of each atom in X compound, to calculate the empirical formula, you need to divide each number of moles to the smallest number of moles we have. And the smallest number of moles here is 0.015, which belongs to the oxygen atom. And let me show it to you. We have carbon atom, we have hydrogen atom, and we have oxygen atom. And for carbon, we have 0.060 moles. And for hydrogen, we have 0.150 moles. And for oxygen, we have 0.015 moles. So we divide each to the smallest number of moles, which is 0.015. Okay, so we have, for carbon atoms, we have 10 hydrogen atoms, and we have 1 oxygen atom. And let's check, is it an empirical formula? Is it the simplest whole number ratio? Yes, it is. So we can write it as C4H10O. This is the empirical formula of the X compound. After we find it, the question says find the molecular formula of the compound. And to find the molecular formula of the compound, we multiply the empirical formula by any number n, and you find the formula. So to calculate the molecular formula, first we should find the molar mass of the empirical formula. And let me do it for you. 4 times 12.01 plus 10 times 1.01 plus 16. And what do we have? We have 74.14 N. And the question says, let me show it to you, the molar mass is 74.14. So if the molar mass is 74.14, then N must be equal to 1. So it means the molecular formula is the same as the empirical formula for this question. So this is the molecular formula, and this one is the empirical formula. Okay, this is all for today. I hope you understand it well. If you have any further questions, you can email me anytime. Thank you.